So yeah, my name's Ryan Simmonds, Specification Development Director for the northern area of Aliaxis, and obviously this evening's session is going to be on barrier pipe for potable water supply in contaminated land. Do you want to go next slide, Ollie?
Yeah.
So just as a contents on sort of the learning goals for this evening we'll give you a quick overview of who we are and what we do. Contaminated land, pipes that can be used in contaminated land. What is a barrier pipe? Obviously the benefits of a barrier pipe system, some reference projects, and product portfolio.
Mm-hmm.
So for anyone that doesn't know, obviously Aliaxis are a worldwide business. We're experts in fluid management solutions. So if you like, our purpose is passionate about creating sustainable systems for water, gas and energy, and leading industry in a way that anticipates the rapidly evolving needs of our customers, ensuring peace of mind for future generations. So in terms of a glance of who we are, 3.1 billion euro revenue turnover, 16,000 colleagues. There's 120 plus distribution centres in 45 countries with 80 plus manufacturing sites, which includes 1,400 injection machines, 600 extruders, and over 12 brands. So in terms of brands, footprint. Sorry, Ollie. Obviously, and this is the global. So we've got EMEA, which we sit under, which is Europe and Middle East, APAC, and then America. So this sort of gives you the split. And then in terms of brands that you'll more commonly know, Volcathene, you might know, Durapipe, Marley, Hunter, PLX. They're the sort of brands you've probably covered. Filmac, and then obviously GPS, which are the PE pipe systems. So they're, and Protector Line is obviously a barrier system. So they're the brands that you'll most commonly be aware of over the period. And we've been owned by Aliaxis, which are a Belgian-based business for sort of 20 plus years. But it's obviously they've got brands across all the world in terms of Nicole in France, etc. Go on, Ollie.
Yeah, so that brings us on to the content. So yeah, my name's Oliver Latham. I'm the technical manager here at Aliaxis. So today we're going to be talking about contaminated land and solutions to mitigate the risk of contaminated land. So what is a sort of potential future contaminated land? What is contaminated land? So an example of a potential scenario where contaminated land might occur would be a petrol station, where you've got the potential for leaching of hydrocarbons into the soil, and that would be an example where you'd need a barrier pipe. Similarly, brownfield land for housing sites. So these are areas that have previously been developed. They've been utilised for industrial or commercial processes, and there's a risk that the potential soil is contaminated with sort of hazardous waste. So that's typically where you would need to use barrier systems. Often people will deploy them irrespective of previous use. Feel free to ask questions as we go. There will be a point at the end for questions as well. So in terms of pipes and contaminated land, this is the interaction that occurs if the improper solution is deployed. So if a system is deployed where the wall is permeable, then contaminants will pass through and then be introduced into the water supply, the potable water supply, which obviously is hazardous to the people or animals or whatever consuming. So it's very important to make sure that these ground contaminants don't migrate. In terms of pipe material, there's a few different methods, a few different materials. So barrier pipe is a composite of plastic and metallic material. PE pipe, polyethylene, PVCU material, polyvinyl chloride, typically unplasticized, wrapped steel, wrapped ductile iron, and copper are all materials that historically and even presently are used for the conveyance of water in contaminated land. So the important thing to consider when specifying, when developing a contaminated land solution, is the pipe selection tables, which are from the UK WIR report. So these documents, these basically detail out the pass and fail levels for materials. So the first example is polyethylene, and where there's a numerical figure, that is the level of which can be present in order for the system to offer permeation resistance. Where the word pass is present, it means that it's resistant. So polyethylene has some clear top levels in terms of all those things detailed there. So things like ketones, ethers, mineral oils, various other elements. And if they were to exceed those levels stated, then there was the potential for permeation and further issues. Similarly, from a polymer perspective, you look at PVC, it has better levels on some, lesser levels on others. But yeah, again, there's clear and tangible levels. Once you move to metallic materials, things like steel, ductile iron, copper, pretty much across the board, they're resistant to permeation from those elements detailed. However, the main issue is around corrosion, and the issues of corrosion in depending on pH levels of the soil. So that's where a barrier pipe, a composite pipe material, really comes into its own, because it offers the resistance of a aluminium or a metallic material, but it also offers the flexibility in terms of installation and movement around site, compared for polymer. So it's a best of both worlds, for example. Was there a question there? Sorry, or
no? I mean,
no?
we deal with utilities on sites.
Oh, okay, brilliant.
And I've noticed,
Yeah.
there's quite a few sites where when the ground the GIS and the ground surveys and that come back, the water companies seem to be a lot hotter on picking up any sort of contaminants.
Yes, we're a lot more prevalent, isn't it? Definitely.
Yeah, we were on a greenfield site, and there was there was about five, there was 7, 8, there were 9 industrial, commercial, logistics units, and there was at the one point on the field, which was previously a greenfield site, there was a hell of a lot of VOCs there, and they just insisted on barrier pipe throughout.
Yeah, like I said earlier, often they'll just put it in as a standard prior to even doing a soil analysis. They won't even go through the expense of doing it. They'll just deploy it. It's quite common.
Yeah, well, unless you provide the full analysis. Now, I think the water company default position seems to be barrier pipe unless otherwise, until you provide the level of certainty that after.
Yeah, 100%. Brilliant. So in terms of what is barrier pipe, sort of generically, so it's basically a composite pipe as I described. So it's typically a polyethylene protection layer on the exterior with an aluminium interior with a bonding agent, and then another PE hose pipe, which is what's exposed to the conveyed fluid. So yeah, the aluminium layer is typically very thin. However, there is a couple of different types, which I'll go into in a little while. So the benefits: saving time and cost of soil sampling, savings on landfill, sort of protects the structural integrity of the pipe. You haven't got any issues around corrosion, and you're applying sort of a peace of mind solution, really, when you're deploying a barrier solution. And when you do deploy said solution, this will occur. So the present contaminants will be unable to pass the aluminium layer. So you get that full protection, that full solution. It's also obviously a PE, comes with its PE strength as well. So you're talking sort of pressures up to 16 bar, STR 11 rated in terms of wall thickness. So it's got the robustness, but at the same time will offer the protection of permeation and corrosion. So typically, sort of barrier system should consist of both pipe and fittings as a solution. manufactured in accordance with BS 8588. Joints are required to not only be leak proof but also impermeable to ground contaminants. So it's pointless deploying pipework that's resistant and then deploying fittings that are not. So it's very important to have a full system that's approved for said application. And obviously for potable, it's RAS approval is paramount. So these are the two types I was referencing. So historically, a lot of barrier pipes were type B. So that's where the aluminium barrier or the metallic barrier is actually integrated within the core of the pipe and it isn't removed for jointing processes. Whereas with the type A, which is more prevalent nowadays, the area which is being fused or jointed, the aluminium barrier can be removed easily just by mechanically scraping. So it allows the electrofusion jointing methodology, but still retains the aluminium barrier for the main run of the pipe. In terms of jointing technologies, electrofusion, butt fusion, the welded joints. So electrofusion is a coupler with an internal metallic coil that's heated via a current and then provides a fusion. But fusion is the same in terms of introducing heat, but the heat is introduced at the end of the respective pieces of pipe. It's then a lot pushed together within an aligned piece of equipment and then creates a nice clean bead around the exterior. So they're both fully PN16 pressure capable. There's no benefit to one or the other. Similarly, the same can be said for the mechanical joints. Typically, they're used for smaller bore pipe work, so your up to 63 mil is most common. You've got the two types. You've got the mechanical compression with the insert, similar to sort of a Filmac style fitting you may be aware of. However, there is an insert, which is the green element you see there for permeation protection. The same on the mechanical style. It's a clamshell exterior with a metallic inner core that's again inserted into the bore of the pipe. So you get some nice benefits with the fusion as well, where you're not interrupting the flow. There's nothing that's sitting on the inner bore. It's full complete bore all the way through. That's just highlighting that fact. So talking about the end loading benefits of fusion. The welded joints will last a lifetime of the pipe, so that 100 years typically you'd expect to see a barrier system deployed for. The fusion joints will align with that, and the no bore issues like I discussed. So there's nothing sitting on the inside of the pipe. It's all welded via the exterior. When you talk about butt fusion, it's important to ensure that the SDRs are the same. So the SDR rating refers to the wall thickness that directly correlates to the pressure capability of the system. So the correct methodology for butt fusing, the second picture there, is either SDR to SDR11 or 17 to 17. You wouldn't want to mix and match as shown on the far right. However, for electrofusion, for using couplers, you can mix and match between the SDR ratings. The fittings are typically universal for all SDR ratings, up to 17.6 typically. In terms of the preparation of a welded joint, it's important to scrape. So that's typically done by mechanical means that will remove the outer PE layer, bonded layers, and the aluminium barrier. That will allow a full polyethylene fuse to occur, and it will leave sort of virgin polymer below, because when pipe is manufactured, extruded plastic pipe, it will oxidize with the air, and that will slightly change the material properties. In terms of generic characteristics for barrier pipes, they're tough, they're strong, typically made out of a PE100 material. PE80 historically used to be a bit more prevalent, but the market is moving towards PE100, which is a superior material in many ways. Like I say, service life typically 100 years can be sort of confidently expected, but the general consensus is it could be much longer than that. Lightweight, flexible. You've got full end loading, so things like thrust blocks typically aren't required for the use when you're using polymer materials. Typically, they're required for metallic. Some of the standards, you'd expect to see all the standard stuff really. So the RAS approval, the WIS approval, the relevant BS standards, as well as Reg 31 as well would be standard approvals you'd expect for a barrier solution. Excuse me, sorry. So in terms of key benefits for client designers and installers, the barrier system typically provides superior performance over traditional metallic and plastic systems. It protects against contamination, as well as the varying pH levels. So it's like I said earlier, it's the best of both worlds. Ease of installation, sort of variety of jointing technologies. You're not limited to a certain methodology. You can utilize butt fusion, electrofusion, and multiple types of mechanical couplers. And they're fully RAS approved as well. So you can obviously prove water quality. Just in terms of us and some reference projects, so we work with people like Anglian Water. Nice project here for a brownfield site. So this was a 3 kilometre mix of 355 and 450, with spurs going off at 225, 180 and 90. So this is sort of a run of the mill, typical type deployment for a barrier system, and it's sort of accepted by a lot of the water authorities, which we've already talked around. This was a renewable plant, similar sort of deployment, bit smaller pipe, but the methodology is exactly the same. Finally, quite a big one. So this is within a built-up area. So this is what you might see near your house in terms of when they're digging up the roads and changing the pipe systems. This was a 400 to 25 mil system. So 400 mil would be the main artery with ferrule takeoffs going to 25 mil to each of the dwellings. 15 kilometers long, deploying a butt fusion methodology. So on that picture there, that's a butt fusion machine, which allows the system to be jointed sort of on site via generator power. Butt fusion for large sizes is the most common jointing method. And that was for Welsh Water. So just in terms of our system, the protector line system, so we offer sort of 63 up to 630 mil on the straight lengths, standard coils up to 180. We've also got the 3C, which is basically pre-cleaned, so it removes the need for the washout process on site. Doesn't remove the need for chlorination if that's a requirement, but just it removes the chances of any elements, any solid pieces that might be find their way in there during the transportation process. Electrofusion fittings up to 630 mil. Mechanical, like I say, is on the smaller sizes, typically for compression, so up to 63 mil. And then the other mechanicals, the clamshell style, are actually available up to 180, but typically you'll see a migration, certainly in England, to fusion north of 63 mil. Bell offtakes, so these are a means of branching off on the main artery without having to introduce a T, which is obviously a lot more long-winded from an installation process and more cost-effective. So you can deploy a ferrule, and that will allow you to branch off at 20, 32 and 63 on hose pipe up to 355. And then boundary boxes, so they sit on the building boundary of a house or another building, and they allow access to the system via, so you can isolate, you can check the water meter, and those are fully contamination proof, so they fit in line with the protector line system.
You say ferrule takeoffs up to 355?
Correct, yeah. So hose pipe up to 355, yeah.
Right. So right. I seem to remember that only going up to 250 for some reason. Perhaps I've got that wrong.
Yeah, I'm hoping this presentation is correct.
But, no, I'm sure it's
yeah.
right. I'm
Yeah,
just
yeah.
probably there. I remember I used to work with it. It just used ferrule offtakes all the time.
Yeah.
Even if it wasn't protector line pipe work, because it was just so much easier and quicker than trying to do put the T and that onto there.
It is. Yeah, it's so labour intensive, isn't it? Trying to introduce a T or something like that. But yeah, I'm 99.9% sure that is correct.
No, absolutely.
I know they've developed the offering quite recently in terms of to capture more of the sizes just because of the ease of installation. So yeah, there's a nice variance there, definitely.
Yeah. And they said the 3C and the 3CTH was the you can use to do away with the need to flush.
Correct.
You were saying.
Yeah.
And is that
so,
accepted by all the water authorities?
Typically, I'm not too au fait in the extent of deployment, but I know in terms of pre-cleaning, it's accepted.
Right.
Typically, there might still be a chlorination requirement.
Oh, chlorination.
Yeah.
That. It was
But
just...
but yeah, it's definitely accepted in terms of the robustness of the capping off process, and I've not heard of any issues in terms of contamination.
It's right. That's just worth being aware of. That is.
No, definitely. Yeah, but
yeah.
So that's the end of the presentation. So I don't know if you've got any more questions, Phil or Joss, if you've got any.